Oh, yes, it started recording. You're good. We're golden.
Okay, can you all hear me fine?
Yes, we can hear you fine. Please post questions on Q&A. Mary, I know that I have missed one of your questions. I will come back to it at the end. I put a thumbs up there. Go ahead, take your screen. Take it away, Saurabh. Thanks for joining us.
Great, thank you so much, and thank you for inviting me to this event. This is my first time here, so I'm pretty excited. And yeah, I was initially not sure how is the audience gonna be and things like that, but looks like you our guys are awesome. And today I would be talking about systems engineering. I would be taking you through some of. Can you
One,
hear me?
there is something that shows up in Canva. Do you want to close down that thing? It says manage Windows, da 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 da. Just say allow and close it. Don't say block. If you say block, it's
Okay, hold on.
it's okay. So sorry about that. I just saw that it's popping up, so it might when you do that, it might not be recording properly. I think you're presenting the wrong screen.
Let me just say present.
Okay, close the other one. I see two screens. One is the presenter window. One is the audience window. Okay, yeah, cool.
That's the easiest one.
Oh yeah, good, 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 super.
Yeah.
Sorry about that.
So yeah, thank you so much. Hope everyone is able to hear me loud and clear. So I'm gonna walk you through some of my experiences dealing with systems at scale based on my last few years of experience. I'll be walking you through what I have learned over the course of this n years, and we probably will dig into some of the details and also walk through some of the high level things. So, just to structure the talk, I have like around 20-25 minutes worth of talk here, around 10 to 12 slides. I also have a small case study that we'll work through together just to understand how a SRE would react and what I mean, set of learnings we go through, we'll try to implement those learnings in that incident, and hopefully that will make this talk more engaging. So let's see. Also, I would love you to ask as many questions as you can, because I feel that's what would make the talk more engaging, and it will also keep me motivated. So feel free to ping and raise your hand and like ask questions. Uh, and after the talk, also you have ample time, and anyway, like I don't mind questions. I would in fact love to have those. One quick disclaimer: whatever I say is like all my personal opinion, doesn't really reflect that of Google. But yeah, let's go deep dive in. Wait. Yeah, so I'm Saurabh. I work for Google Search. I work as a senior site reliability engineer. And what my day to day life here is basically managing, maintaining, and ensuring the Google search that you use on a day to day basis is reliable, it serves your purpose, and it's basically uh, you're able to get those results in those milliseconds of latency. Like, you click something, you search for something, and you get the right result in those 900 milliseconds or 800 milliseconds, and that's where most of our energies really go. We have been working a lot on optimization. We have been working a lot on delivering those excellent customer experiences, and I'll probably walk you through some of those things now. But yeah, and yes, over the course, we'll also talk about what are the foundational things that you should really be keeping in your mind, like, when you're designing this large scale systems. And does it really matter whether you're designing a small scale system or a large scale system? How does the landscape really change? Like, how you should be evolving while you're developing the systems. So, uh, what is systems engineering? I think it is a very core question to answer. uh, in my opinion, systems engineering is more like a multidisciplinary field where you're talking about reliability, you're talking about scalability, but at the same time, you're also talking about cloud security, you're talking about compliance. And I just cannot emphasize how important cost management is. It's Supriya just touch based on. And I really love the talk. And I think it is one of the most important things we have been dealing, like, based on my present company and also my previous companies. I think cost was one of the paramount things we have dealt with, and we have invested a lot of energy in, like, optimizing for infrastructure, optimizing for what resources are being used, and then, like, drilling down and having that visibility. So all these things put together essentially is what systems engineering is. It goes all the way down from Linux kernel. You need to understand, like, how Linux kernel operates, how the networking stacks operate, how the disks are operating, how the architectures are laid out, and, like, how these different components can interact with each other in a cohesive manner. And while this is happening, if there are any incidences, if there are any issues, you have the right tools, have the right technologies to basically go in there, fix those, and, like, ensure that the system is up and running. So to some extent, that is like what a systems engineering field is. People have really defined systems engineering in, like, different ways, and the people who deal with systems in are being called as site reliability engineers, DevOps engineers, I think system admins. uh, but in my opinion, I don't know what's really the differentiating factor between those, because holistically, if you look at each of these roles, they are they are in a way trying to solve the same problem, but their approaches might be different. And I believe all of these things essentially boil up from the same thing. Like, you basically want to ensure that you are delivering a very awesome customer experience with least amount of resources, and also scaling the system for the user needs. So yeah, that's essentially what systems engineering is. Yeah, by the way, if you have any questions, please raise hands. Otherwise, I'll just go to the next slide. So, what is SRE and how it has really evolved? I think SRE is something that Google really started, but it has been there years before that. Even Google came up with this branding. Google rebranded what systems engineering was, or what, sysadmin work was, or what DevOps was, as a site reliability engineering term. Uh, for due to certain needs, like, it wanted to, like, coin this term, bring up some additional things into it, and, like, project it to the world, like, this is what this new field is and how exciting this would be. Part of this was a branding idea, part of this was, like, ensuring that your energy is invested in the right efforts with the right words you use. So it essentially started at a Google practice. Ben Turner was basically the person who came up with this uh, term, site reliability engineer. And this is how, like, it has evolved, like traditional IT operations, DevOps, and then what you see now is site reliability engineering. This also goes alongside with the evolution of IT and the, what do you say, software ecosystem evolution. 1990s, 2000 probably was the time when we had things like mainframe computers. We had data centers somewhere in remote locations, colos, what people used to call those. There was a lot of things, like, you have to lift the server, place it in a rack, ensure that the wires are tied up, ensure that it is serving. It was probably serving like few kbps, I don't know, maybe mbps. I was not even there back then, but that was the rate at which data was being served through those servers. They were even supercomputers, but again, those were not so distributed as to what we see now. The challenges and problems were very different. Moving forward to somewhere around 2000, we had a thing called dot-com burst. Bunch of millions of sites came online, like, thousands of sites came online. People started designing or considering internet as the new way to serve different experiences, and that's where, uh, on the hindsight, the need for ensuring those experiences stay consistent really grew. And that's where, like, people came up with these ideas like DevOps engineering and things like that, where you're essentially bringing developers and operations together to basically serve a more reliable experience that could encompass things like ensuring that you have a release process, ensuring that you have certain monitoring checks, and you're following certain guidelines, principles, and things like that.
Uh,
Fast forward, yeah.
Sorry, there is a question. It's all about SRE is a generalist. Does it focus more on one point than the other? Business needs versus technical needs. Sorry about that. I missed that.
Yes. So though SRE looks like a generic term or a general term, I think you can certainly develop expertise in specific domain as far as site reliability engineering is concerned. Now it all depends on the organizational needs, and it also depends on your expertise. Though the term is very broad, over here at Google we have SREs, which are again, I mean, subdivided into network SREs, were very domain specific to networks. There are SREs which are more specific to databases and backends. So a backend SRE. So I mean, based on your expertise, based on what your niche area is, there's like a lot to be done. But at the same time, you cannot be a doctor of just it's a common term that I've heard, you cannot have understanding of what's just happening in brain, and then if someone comes up with a pain in the hand, you're like, oh wait, I have zero idea on what's really going on there. So you really need to have a broader understanding of the world, how things are operating, how network stacks are laid, how bits are sent over the network, what are the different failure scenarios. But then you have your own niche with you. So there's a broad understanding of the world, and there's also a niche area where you are expertise in. Hope that answers your question.
Does this differ in different companies, Sarah? Because
Yes, it does differ a lot. At least in last three companies I have worked with, I think the definition of site reliability, the definition of, I mean, DevOps changes place to place. Uh, it changes a lot when you're working with public clouds like AWS, Azure, GCP. The set of things that you're dealing to ensure reliability on those infrastructure is way different than what you would do at Google. Uh, it would be way different if you're managing, maintaining huge large Kubernetes clusters versus you are actually managing large pile of uh, what do you say, physical data center infrastructure. So over at Google, like, we deal with a lot of this thing called Borg, which is which basically is a precursor to Kubernetes. So Kubernetes was like a fork that came out, but it provides you with a lot of knobs and bolts to tune and tweak a lot of optimizations in there. So I think the role of SRE also essentially changes from organization to organization, from the scale and the size of the company. Because the way I look at it is based on the size of the company and based on the users you're serving, your your expectations of reliability from your application changes a lot. The problem domain itself changes, and that's the reason your work and your work profile also changes accordingly. I have a slide, I'll actually go deeper into that part.
thank you, thank you.
Yeah. Where was I? So yeah, last probably 2016, 2017 onwards, we've had this burst of public cloud infrastructures, AWS, GCP, Azure, Oracle. I don't know, like bunch of other cloud providers have come in, and like that has really changed the way people have been pursuing infrastructure management. You don't have to set up those racks, you don't have to set up those networks. You basically can ensure, you can codify your infrastructure. Part of the responsibility of managing this infrastructure is kind of rented out. That's what I would say, like it is given away. And there is another part of the reliability which you own as maybe a sorry organization and the company, in case you're on a public cloud. Basically the lot of low level stuff, like ensuring your whatever, like the low level, if is your data center heating up, is what's the cooling story of your data center, how many disks have gone bad, and like how often you have to replace those. I don't think any of one of us have really dealt those in like last 5 years or 10 years, unless and until you are really working on low level stuff and you're really working on the physical infrastructure. But with AWS, Azure, and GCP and those kind of things, maybe you have new problems to solve, you have new things to solve, like cloud compliances. uh, One of the interesting things about cloud compliance I've seen in past 8 to 9 years is like 2013 to 14, people were hesitant to go on public cloud. One of the reason was compliance, like they were like, hey, I have this application, and if I go on public cloud, am I gonna get the assurance that I'm going to be compliant, I'm gonna be like secure, because you're essentially running somewhere else. But last 7 8 years, things have really changed, and it has actually flipped. People want to be on cloud because it gives you more compliance, like FedRAMP, half of the responsibility is done. One of the company I was working with in the past, it was so easy to, I mean, it was I would say it was so easy, it was relatively easy to, I mean, PCI HIPAA are certainly a thing. FedRAMP is like a compliance that is required if you're dealing with like federal governments and things like that. It has a very high standard as per as what is running in your infrastructure, where your machines are, how those are like configured, what version of packages you should. There's a totally separate story as far as like uh, what packages get installed in your machines. Like those need to be like FIPS compliant, and there's things like that. So and there's a lot low level stuff down there, but some of these things, because you're on now this cloud providers, it's you're like just giving this responsibility to the cloud provider, and because cloud provider is managing this on a wholesale basis, it kind of can assure you a lot of those things, and then you can focus on what is more important for an application, and like scalability and the your part of the show. It's more like a shared responsibility model. You take your own things, but it helps you basically divide those things very quickly, and where lot of small companies cannot really invest a lot of energy there. I think that's where the delta comes in. So that also, this also impacts the site reliability field a lot, because back then you had to deal this entire spectrum of things. Now you have to be more focused on what is more important for your company, for your infrastructure. But yeah, anyways, like as this entire story evolves around changing landscape in the compute industry, I think something has really changed very constant, and I think that is more like a uh, foundational mindset and proactive system thinking. So I think that's what we are covering in the next one. But any questions?
Any questions for Saurabh, folks? I think we can continue, Saurabh. I don't see a Q&A, but I am sure that there will be a lot more when you start
Sure.
talking.
Yeah, sure. So day-to-day life of an SRE, I think that's a the reason I took this slide is because this is something that gets asked quite often, and I think I kind of explained it a bit in my previous slide also. Like it changes a lot from organization to organization. I can talk on what I do these days as a site reliability engineer. So there is like the traditional housekeeping work that you have to do as far as your infrastructure is concerned. That would essentially mean you have to monitor your infrastructure, you have to invest in right SLOs and SLIs, you have to do capacity planning, and you have to invest a lot in automation. Now we'll try to go deeper in the individual aspects. So monitoring, looking at like collecting the right metrics, ensuring that you have the right infrastructure to collect all those metrics, it's scalable enough, and it is monitoring the right aspects of your application is very important. And I think that's where a lot of energy of all the SREs really go in. Like it's not just like you're just monitoring CPU and memory and like network latency. With monitoring and especially with alerting, I think we have a theory here. Like we don't alert for the cause, we alert for the symptoms. Like what is the symptom? Like if to explain it in a very easy language, like if you have fever, you go to a doctor, but the actual cause would be something else, but you would actually just page for fever, and then it's the job of the SRE to basically debug and figure out what could be the probable cause, because causes could be spread out in 100 ways. You don't want to get alerted 100 from 100 sites because your latency went up. So you would get probably get paged if your latency is high, or if you're getting error for some service, and then you map it out and you figure out the root cause and things like that. But identified what would be the right metric of success is very important in monitoring. And there is an entire domain of site reliability engineers who work on the monitoring part, at least at my present company and also at previous companies I worked with, monitoring and logging. So uh, there's a big cost aspect to monitoring and logging, which I think even Supriya would agree to, because companies spent a lot of money on monitoring and logging,
Mhm.
storing these logs. See if you're using things like Splunk and other. I mean, there's a huge cost for monitoring and logging, and you have to bear with it.
Hey,
And
there is a question for you, Saurabh. It says that Mary asks, for incident response, are you working with security team? For capacity planning, are you working with admins and program or project people? On which task do you spend the most time on?
okay, so if specifically what I do, I am on Google search core infrastructure. So I spend most of my time on basically optimizations for Google search. So consider it as a hub and a spoke model. So we are at the hub part of it. uh, and we do work with security engineers, or I mean, if there is an incident, yes, we do have to work with the respective team that would be impacted, affected, that would need our assistance. It's not just the security folks. In case you are, like, in easy terms, if you're an on-call engineer, if there is a DDoS attack,
Hmm.
have to work with security engineers. I mean, you cannot know everything, right? You have automation in place that is gonna, to some degree, mitigate. You have to invest a lot of energy in building that automation, because I can talk a bit on this. So DDoS is a very tricky concept. Identifying a DDoS attack takes a lot of energy. There are thousands of tools out there to identify and, like, mitigate DDoS attack, but preventing DDoS 100% is almost next to impossible. And that's where a lot of energy, a lot of automation, and I think with things like AI and stuff, uh, to some extent this is getting easier. But you imagine, like, you cannot impact your real users, and like while this is happening, you need to have security engineers on your back, like, helping you figure out the right things, and like ensuring the right customer comms are sent out and things like that, or framing things, or investigating those DDoSes and things like that. Packet analysis is another thing. um, Probably during the mitigation phase you might not need a lot of that work, but maybe while actually investigating why it happened and why it breached all the initial layers of security, you want to work with a security, I don't know, like CISO, chief, I mean, security on callers, or whoever is responsible on that team. I think the second question was of capacity, right?
Yes, it is about for capacity planning, are you working with admins and program or project people?
Yes, we do work with them. I think capacity is a very hot topic, as I said. We as SREs have to basically ensure the cost reporting from your infrastructure is as accurate as possible. We also build the tools to ensure that this capacity, we try to eliminate as much as possible human in the loop. So it's not like we manually figure out, oh, there's like X number of requests, so you need like X servers and X Y this. There's a lot of automation in place, and that's like the entire pipeline. And building that pipeline is what we do. So uh, you have to deal with a lot of project managers, because or even admins. I don't know what admin really means here, but a lot of capacity planners, if you say, we do work with them a lot, because at the end this entire cycle eventually boils down to how much capacity are you really going to need to serve X number of users. And that way they have to ensure they are ordering those many machines in the hindsight, like, the way, if you're on AWS cloud, you do your yearly accounting, like X number of uh, M type instances and Y number of C type instances based on your compute requirements and memory requirements and whatnot, um, or X number of GPUs because you are and CX large or C5X large and whatnot. Based on your application benchmark and performance, you'll do a lot of tests, but ultimately that number counting and things needs to be automated when you come up with a final number. That's what we built. The ordering part, the provisioning part is what's done by uh, the planning folks and like the other teams. That's probably not SREs involved in that process. The procurement part, and if I'm correct, yeah. So yeah, in case of public cloud, it's probably way easier. In case of things like Google, it is way complicated. But it's still there, like on a day-to-day basis. Yes, I'm also involved with a part of this work.
Okay. Yeah. She says that thank you. Understood. Admins equals system admins.
Okay, so SLOs, SLIs are also very important. I think the defining these SLOs is a joint responsibility by like SREs and also what would you call that, like product owners, because they are the ones who basically come up with the product ideas and like all the management aspect of it and things like that. They are like the application owners, but SRE's responsibility is like ensuring those SLOs are already always maintained, and we have to really work with them in ensuring our monitoring metrics, our service level indicators are essentially mapping to those, like, if there are errors in last quarter, what percentage of those were like customer impacting. Come up with a standard SLO if we are breaching those. Come up with a plan so that it is mitigated in the next quarter with the right set of things and tools. So we have to work a lot as far as ensuring those SLOs are there. Um I mean, one funny thing about Google is people use Google to check if their internet is up, and they kind of do like ping google.com. It is as analogous to your internet is up or down, but ultimately it is also a website, right? So that's the backstory here is there is a SLO of 99.29s or four nines. I mean four nines SLO, and there's a lot of effort that goes in, and part of it is like owned by SREs. So that those things are very important. The last thing here is postmortems. I think this is a huge topic, and SREs are to a good extent are kind of the soldiers who are like standing on the front line, uh, ensuring that they are protecting that customer experience, and then what happens afterwards is what uh, the responsibility of SRE is to basically lead and like bring all people together, ensure that it is communicated, ensure that you come to a right logical conclusion on what could be the cause, and like draft it down, work with the developers or whoever is owning the final solution to that incident, and ensure that it gets deployed and like worked out in the right way. So there's a big responsibility of an SRE that even I do on a day-to-day basis, is basically dealing with these postmortems, and it's a big task. Like dealing an incident is another thing, but dealing with postmortems is totally different ball game altogether, because you have to invest a lot of energy in basically digging down through the problems, and essentially what you see is not always the problem. There's always a way deeper problem that you will come through after you have figured out like these five things. There's probably like the sixth thing that you will come through during postmortem. So it's a very interesting and it's a very challenging thing. Yeah.
Hey, there is a question for you, Saurabh. Oh, yeah, five nines uptime. How are the nines determined? Is it the business that sets up the level of uptime guarantee it delivers, or is it the customers? I think it's should be the
So
business.
5 9 is super high number. 4 9s is a good number. I mean, yeah, fine, 4.5 is what probably Google does, but um, these numbers are to some extent determined by the business. Like one of the companies I worked with in the past, this was essentially the selling point, right? Because if your website is 100% available, I mean 99.99% available. That's like a metric that they used to use to sell the product to the customers. It was a single sign-on company, so if your product is available, four nines or five nines, that's like more like a selling point for the marketing folks. Like, but on the hindsight, it's just SRE's responsibility. So um, I don't think anyone would actually go and just set the target to be 99 point, I mean, five nines, and then work backwards towards that number. It doesn't really work that way. It is a even it's a gradual progression, and a lot of it really goes while designing the system. So I think that's where the foundational design principles come into play. Like, maybe Google's whatever XYZ application is already set up, but if you're designing a new system, even uh, at the present job, we come up with the design theories and like um, what do you say, the architecture in a way that we will target a certain nines of availability for this application, and then gradually keep adding nines, additional lines, and adding each additional lines is basically a exponential investment in resources, exponential investment in automation, exponential investment in monitoring and observability. So each line comes with a lot of tax basically. Yeah. Hope that answered your question.
Saurabh, I have a quick question. Then it becomes a responsibility of the site, SREs, to keep the site up and running. Because if there is an outage, for an instance, WhatsApp goes down, or even any website for that matter. So what would be the case in the when they do the postmortem? But there are times that there is still it still happens. It's not that it doesn't happen at all, but how are some of the measures taken by the business saying that, hey, we had an incident, yes, it was down for 15 minutes, 20 minutes, or even for 3 hours or 4 hours, like WhatsApp happened before. So what are the measures do they take in that case?
Yes, happened with Facebook, happened with WhatsApp. I can name many other companies, AWS S3, and I mean many other companies. It has happened. Sites were down for not just 5 minutes, but half a day. It was like last year where they messed up with the BGP routing in a data center. Ah, depends. Like, businesses have a very different approach. I mean, companies have these contracts with their end users. Uh, I mean, it differs a lot from businesses to businesses. If something has really gone bad, I mean, you cannot go back and fix it. That's what I've learned. Uh, there's a good thing. What I have learned is I have been part of a few incidents, and I have been cause of few incidents, and that's how I've learned. But the fact is, that's where like you don't play the blame game. You probably work in a way that this thing doesn't really occur. There's no great way to basically deal with these kind of things. I mean, if there is a customer contract, I've seen customers getting compensated for those breaches and things like that. Um, so it's a joint responsibility by business, and it's also a joint responsibility by SREs. And you always target, like, if there is four nines, will ensure that our availability is four and a half nines.
Mm.
So that's how, I mean, we as SREs put our energies and all our automation and tooling to ensure that we are there. And we do a lot of capacity planning, like, there is a lot of mitigation that is in there. So I mean, why would something go from four nines to three nines?
Mm.
It would only happen during an incident, and if you don't have a right mitigation strategy in place. So what we do as a workaround is, like, we build our architecture, but at the same time we also build a lot of mitigations in a way that uh, you don't fall down from four nines to three nines or like two nines. We try to mitigate that problem quickly, and that's how, I mean, we kind of work around the problem so that things are there. You plan your capacity, like, there is like always, if you need X, you'll always plan for X plus 2. It's like a
Mhm.
simple basic philosophy, but there are many other things we kind of do to ensure that we are We are just over provisioned to ensure we are available, but we are not over provisioned to ensure we are not going above the capacity planning. There's always this thin line, like, if you can, if can you like always throw money at the problem to solve the problem, or you can basically invest in automation. So that's the thin line. You throw money at the problem and you'll always never be down. Like, you can just like build 10 data centers and
Mhm.
have it run at 10% utilization. I think even if you have any issues, those probably would get mitigated way early. Or you run five data centers, maybe run them at like 60-70% utilization and invest in right automation tools. And that's the sweet spot where SREs come in. I mean, if I can, I should have that as a slide, but yeah.
Okay.
Next slide.
Yeah, you can move on.
Yeah. So yeah, so these are like the building blocks for large scale systems. In short, what I'm trying to say here is you need to invest in right architecture, you need to invest in right observability, you need to invest in right release processes, build architectures in a way that they are fault tolerant. There is enough resource isolation between different components of your system. And while you're doing that, there is lot of investment into testing, QA, black box testing, so that you get notified way in advance before an incident occurs. And there are scenarios where things do slip through. Like, there's like one of the ways I can answer even previous questions from here is like, um, what I've seen as a gradual progression in uh, last 2-3 companies is like, based on the size of the company, the investment in testing also also changes drastically. Like, my first company, the amount of test coverages we had, the amount of black box testing we had was way different than the second company. And whereas in the third company, it is way lot, like, there is lot of guarding in place so that no bad things can slip into production. And even if they slip, they are blocked at the right stage. And that's where, like, you run a lot of tests, checks, canaries, A/B comparisons, and a lot of back and forth testing, so that uh, that extra nine, you don't really lose that extra nine. There are situations like things are gonna go bad, like, which are not really because of your changes or not because of your um, code breakages. It's probably gonna be like traffic, like things. Consider there's a cricket match going somewhere or a football match going around in the world. It's a big thing for probably Google. It's a big thing for, I mean, or the events occur. So when you have an event, there are like huge spikes. And though companies are provisioned to deal with spikes, uh, that these things could lead to outages on one components or the other. So these things is something where resiliency and caching and those kind of things would help. But again, it's not always predictable, like what would be the size of the spike you can expect, right? um, Probably the last World Cup. I mean, you might have seen some of the tweets by some of the CEOs out there, like, and things were like so huge. Like, this was the biggest traffic Google really received in last 25 years. You just find that tweet; it's there. So
In that case, how do you do any rotations? Because in my previous job, I know that people do these rotations. They get paid right away and things like that. Do you get paid
yes,
or you work in rotations?
yes. So I would be on call tomorrow. So that's what we do. We have on-call rotations. We have multiple on-call rotations for individual components of services. So imagine there are like 100 services. So give or take, for each 10 services, there is an on-call rotation, and there's always a fallback. So you are the primary incident commander in case things happen, and there's also a fallback. There is a second fallback. So we have what do you say, availability even from the human perspective, so that things don't go bad, and there's always a human to look into the issues and solve the issues in case automation doesn't really take it. So one, there is automation that will take care of things. If things go bad, it will automatically either reroute the traffic, either trigger a lot of failure scenarios that are already built in. But not always everything is really gonna consider this corner case, and that's where humans come into loop. And if
Mm,
for some reason, if humans need help, there is like second degree, third degree of people who are there to like join in. And then one of the companies I work with, we really had a thing like a incident session where if things are really bad, it is affecting more than X number of customers. Because this happens like, where you have enterprise customers, you have like they're sharded. So this is a very limited scope of lot of other reliability measures you can take. And one bad thing can affect few others, so there's not enough resource isolation in between those customers, and that could be a problem sometimes. And that's where we had a situations where, like, you have to bring all the devs, all the on-callers together, and not all, but like a group of people, and define what category of incident that is. So let's me give a more concrete example. Like, let's say an incident, you have like 10,000 customers. If an incident is affecting like more than 2% of your users, you would call a flare. If it affects maybe 5% of users, that would be more like a red alert. I mean, just consider, like, so red alert is when like you would have like 30 engineers who would come to your rescue. Flare is when you would have like at least 5 on callers who would come together. So that's how there are internal processes defined, and you as a SRE have to do the right triaging, and you have to have the right metrics at hand to basically deal with those things.
there is a question. I think, Mary, is that questions, or are these your thoughts? Because if you have any questions, please. I think I touched upon, the on-call stuff. And is there any specific question? Please post it on the Q&A.
Sure. So this is something I was talking about, foundational thinking for SRE. I think this is very important. Like, how do you really build these design systems? Uh, for first and foremost, I think every reliable design starts with customer experience. You should really think what your customer experience is gonna look like, and what's the most important thing your customer wants. Um, for Google, serving those results, relevant results in least amount of time is the paramount thing. That's the reason many of us use Google, because it gives you the relevant results. It also gives you very quickly, in the blip of a second, you get like those 1,000 results, or I mean 10, 20, 100 results. That is paramount. Previous company where I worked with, uh, it was fine. Like, if your latency is down by like 10, 20%, what was more important is you're not really serving 500s. And that's where uh, that product uh, required that reliability metric. So our entire reliability story was basically designed around not serving 500s to the user, whereas over here the entire reliability story is designed around, we are not really getting slow. We are ensuring that people are getting quick results and more relevant results. I mean, that this is like the baseline, and there's like a lot behind it, but the most important thing is what you identify, and you build the entire reliability story around it is what's important. There could be different things here, like, the customer experience varies a lot based on the size of the organization and the type of product you have. So the role of the SRE accordingly should calibrate and identify what is more important when you're designing tools and automation for delivering that. Um, Velocity with reliability, I think this is also another thing. Like, you cannot over invest in automation, neither you can under invest. Uh, Depending on the size of the organization, like smaller sized organizations might have less resources. You might not be able to plan all your fun AWS stuff well in advance, or might not really have all those resources to plan all the um, whatever things are required here in advance. So you might not have a engineer working on the cost aspect of it. Just putting it out there. Maybe you might have to invest on something else. But as organizations grow, cost becomes a very, very important thing. So that way you have to really balance between velocity and how do you have refined reliability. Also, few companies where delivering new products, or I would say not products but new features, is more important. Like startups, like they have to be very quick, like feature on feature they'll like release every weekend. But maybe for a larger organization, there is a reputation. I won't say reputation, but there are many things at stake when you are releasing those features, and then that's the reason it slows down the velocity. But and also it also changes the reliability story. So as a SRE, I think you should be aware that your velocity and reliability story have to align with the organization's goals.
Mhm.
uh, yeah, focus on business incomes. Another most important Another important thing while designing systems is you don't design for success, you design for failure. And I think this is something I came across. If you guys know Vernal Vogels, CTO of AWS. So this is something I came across when I was attending one of his sessions, and I was like, wait, I was like just studying as a new grad in engineering college, and I didn't really get like what does design for failure essentially mean. um, Probably now I know, like, you cannot identify a single path of success. You have to be very cynical when you're designing a system, like, hey, this is gonna fail, this is gonna fail, and this is probably might go wrong. And then probably have the right uh, architectural design principles in place while you're designing those systems, so that there is always failure recovery. There is, like, Mm, if you're probably designing for databases, have multiple replicas, failover replicas. If you're like designing your app servers, ensures that they are like replicated multi-region, multi-availability zones. Because availability zones, if you're talking in the terms of AWS, availability zone can go down. There could be a network failure there. I've seen that happening. So all your customers will be offline for that time. So you cannot afford that. So you have to build this in advance. You have to think about those failure scenarios in advance, and yeah, design your architectures. Automating repetitive tasks. I think you cannot really identify at the start what would really need automation. In my opinion, it has to be a gradual business. The way I look at it is, like, if you're a startup or a small company, if you're doing something once, twice, third time, probably start writing a bash script. That's the good place to start. And then eventually you can onboard new tools. You can probably have new configuration management system, and then you can start uh, investing into added automation tools. But investing in automation early is very important. It saves a lot of energy, it saves a lot of engineering time, and it helps you focus on the right things. uh, Embrace continuous improvement. You have to understand that not everything is gonna be perfect. Like, there's gonna be things that are gonna go wrong, and you're gonna learn a lot while doing things. So having that understanding, having that patience, that you are learning over the process, is very important. So you have to have this continuous learning mindset on there. um, Define before you dive. You need to identify the problem well in advance. Try to at least figure out, even if you cannot like figure out the entire problem, understand what you're trying to solve, and then probably deep dive into the problem. And more important, like, foster a blameless culture. That's very important from the incident management perspective. And way you do this is, I have this very important learning I've had is, like, have this team model of learning where, and this is very important for SRE. Like, you have to uh, know many things, and this is a very complex field. It's not that you would know everything in depth. I'm not an expert of everything. I know very few things, but probably those things are is something that I know very well. And there are many things that I don't know at all. I mean, that's where I invest my energies in. But I think understanding that and also keeping your breath going at the same time investing in your niche domain is very important. And it is very important from SRE, like in the first slide I explained, where you cannot be a SRE where you know what's happening in X and you say that Y is not my responsibility and I won't be dealing with it. It's not the way that it works. You need to have a holistic understanding of the entire system so that it works in cohesive manner. But then you need to call in the right experts in case you really need.
Saurabh, just to give you a heads up, the system will kick me out at 6 o'clock.
Sure.
Yeah.
So I think, yeah, we'll just move quickly. I think I probably already covered this thing. It essentially says you have to evolve with the evolution of your organization. From the SRE perspective, your reliability story evolves. So ensure that you are um, you know keeping up with the organizational growth from the reliability perspective, like investing in the right tools, investing in the right technologies with for that size of the organization. It shouldn't be like over investing or under investing. So finding the right balance is very important. Cost investment is very important at this stage, and then balancing out a way of quicker iterations versus like managing the reliability and flexibility is also another stage which is probably important here. Challenges are going to be at each stage, but the principles are, at least in last 10 years what I've seen is the principles at which things have operated have just stayed the same, at least for me. So uh, keep keep just going. um, I had a case study, but I don't know if I would be able to cover it.
Time we can just quickly
Sure,
go through this.
sure. That's fine. I'll just quickly walk you through what I wanted to talk here. It's basically like you have a three-tier application, and if you were to debug this application, and in case there like high latency on your app, let's say your app starts throwing super high latency to your end user, how would you basically go and debug the problem? And I think you probably need to I just want to call out, like you need to mitigate the problem as quickly as possible, because that's where those nines come in picture. Mitigate the problem, call out the incident, involve the right set of peoples, log everything as you are mitigating, ensure that you are communicating the right information to the right set of peoples, and basically bringing those people together is very important. uh, and that's where you basically start the entire RCA and the incident doc. um, and yeah, basically fixing the root cause can happen all the way end of the day in a week. That's fine. Mitigating the problem is more important, and that's exactly what I wanted to convey from this architecture slash case study here. uh, Very quickly, AI is gonna change a big landscape in SRE, and I think uh, probably it will help SREs to be more focused on basically solving, triaging the deep level problems. So probably developing that expertise now is very important, and eventually, most of the high level stuff, especially like observability, operations, automations would be taken over by AI, and I see that is already happening. So, yep, that's all I had, by the way. And if you have any questions, feel free to ask. Now you have
I
2
think
minutes.
we need one more session from you because we ran through it very quickly. But I would love to have you again because this is the first time that I'm trying. I've focused on ops, or we have never done any ops or SREs sessions before. I think it was very very useful, even for people who are like me, who has no visibility towards that end at all. I think we should definitely host another one. I will reach out to you on that. And it was a really pleasure listening to you, both you and Supriya. And I want people to just, if you have any quick final questions, if please don't run away. I do have some things to announce. Saurabh, can you stop sharing?
Yeah, sure.